So now let's start doing this exercise. This exercise will not be that straightforward. For this we have to first explore the hardware connections. Let's first begin with hardware connections. So let's understand how external hardware, that is in our case that is LED, is connected to the microcontroller. For this we have to refer to the schematic of the board. So let's go to the resource section of ST's documentation and let's download the schematic and then we will analyze it. So let's refer to the online documentation of STM32F4 Discovery Board, which is there in the ST's website. So here we have the schematic. So now let's download this. So when you download this, you actually get this PDF file, and I have opened that here. So this is the schematic. So now in the schematic you can search for the LEDs. So if you just browse to this document, here you find LEDs. So these are the LEDs, and here you can see that this board has 4 LEDs. So the part number of the green LED is LD4. This is the part number of orange LED, and so on. So on the board you can identify the LEDs by these names. So these are the part numbers which should be mentioned on the board as well. For that, what you have to do is you have to go to the user manual. So let's open the user manual. And this is the user manual, and you can see that they have explained the board here. And zoom here, you can see that these are the LEDs. This is LD4. This is LED. And like that, it's LD5. So they have mentioned here. So just explore this figure in the user manual. So this is how the LEDs are connected to the microcontroller pin. So the green LED is connected to the pin PD12. PD12 means port D, pin number 12. And the LED blue is connected to PD15, that is port D, pin number 15. So now that leads to our next discussion. What is a port? So now this microcontroller has many ports, and we can identify all these ports by going to the schematic again. If you go to the schematic, so here is a picture of the microcontroller which is used. So this U4A is a part number of the microcontroller. The microcontroller is STM32F407VGT6, and it has many pins, but on this board all these pins are exposed. So in STM32FX based MCUs, each port has 16 pins where you can connect external peripherals such as LEDs, displays, buttons, Bluetooth transceivers, external memory such as EEPROM, joystick, keypad, etc. So if you want to do those external connections, then you can take help of these ports which are exposed on the board. So if you take a look into this picture, all these pins can be segregated into different ports like port A, port E, port D, and each port is a collection of 16 pins. For example, so all these pins actually belong to port A. So the first pin is called as PA0, that is port A, pin number 0, and the last pin here is PA15. And this is a pin number of the microcontroller. So that means microcontroller's 23 pin is actually PA0. That is the 0th pin of the port A. It's like that. This microcontroller has many ports, like it has port F, port G, port H, etc. But only these ports are exposed on the board. So let's move forward. So now let's consider this LED. That is LD4. This LED is connected to PD12 exactly like this. So this is a microcontroller. So this is port D, and at the 12th pin this LED is connected. So now the question is, how do you access 12th pin of port D? So port D is also called as GPIO port D. So GPIO stands for general purpose IO. So these are called general purpose IOs because it can be used for any purpose. Like you can use that to connect external peripherals, or you can use that pins to do some other protocol communication like Ethernet communication or UART communication, I2C communication, etc. So that's why these pins are called as general purpose IOs. So now you have to think about controlling this pin. If you control this pin, you can control the LED. So now the question is, how do you control this pin from the software? So now your goal is to control the IO pin PD12 state either high or low through the software to make LED turn on or turn off. And we are going to learn that. So now for this, you have to understand how these pins are controlled from the microcontroller, and we'll understand that in the next lecture.